Okay, let's start with a geometry node, a box, and a point, which will be our impact point. For the box, I'm gonna use the same values that I used in the final project. 0.5. Okay, and for the point, it really doesn't matter right now. Let me set something like this. Okay. So what's the concept? We have a box and an impact point somewhere. And we want to generate radial lines starting from here. Let me put down the axes, X and Y. So with respect to the Y-axis, we can take a random angle, theta, and adding points along this line until we go just outside the box. What does it mean just outside the box? Well, we can use the relative bounding box function in Vex. It's called relbbox. Which give us some sort of normalized dimensions from 0 to 1 in X and from 0 to 1 in Y. So as long as our point is inside the closed interval 0, 1, I cannot draw, we keep adding points. As soon as our point is outside, which means one of the two coordinates is above 1 or below 0, we stop the loop. Okay, put down a wrangle. We want to create a new geometry, so we use the second and the third input, not the first one. The wrangle runs over detail. Let me create few parameters. And I usually like to secure my parameters like this. So we have always at least one line, no matter what the user does with the slider. I'm using the prefix lines underscore because later on we will create other variables with the same name. So when you create an HDA, you need to have unique variable names. And a seed. Okay. Now our origin is the impact point, which is the second one. And now we can loop over our lines count. Come on. Okay. Okay, now we can create the array which will contain our line points. And the fourth point is the origin. Let's call it current pose equal origin. Int current point, current pt equals to add point to 0, current position. The current relative bounding box vector, oh come on, vector. Let's call it current RBB is equal to RB box 1 and current pos, and append to our array the current point. Okay, this will create just one point, the origin. Okay, now do the following while current RBB dot x is greater or equal to 0 and less or equal to 1, and y is greater or equal to 0 and y is less or equal to 1. Okay, now we have to calculate the next position. Let me go back here. Okay, this is the y-axis. We have our angle. Let's say this is the next point. So, okay, the new y coordinate is equal to the segment length times cosine of theta, and the new x is segment length times sine of theta. So, by the way, we didn't create the angle yet. Okay. Float angle equals to random seed plus float I between 0 and 360. So float y is equal to current position y plus segment length times cosine of angle, which is in degrees right now, so radians angle, and the same for x. X sine the angle. Okay, so the new current position is equal to x, y, and current position z, and the new current RBB is equal to RLB box, which is 1, and current pos. Add point, well, current PT equals to add point 0, current pos, and append to PTS current PT. What I miss? Yeah, okay. This one. Fit questo. Okay, now we have a lot of points because we should increase the segment length, but as you can see here, the last point is always outside the box. If we increase the line count, we should have something. Yes. We have, okay, very close line here. No problem. Now the last step is to create the actual line. This is a polyline PTS. Okay. You see? It's working. Okay. What I don't like is the fact that very often we ended up having a very close line. So I will love to have some control over the distribution, and this is what we are going to do now. So instead of having a totally random angle between 0 and 360, we can say something like float angle average is equal to 360 divided by lines count, and float last angle equal 0. Okay, now we select the angle between last angle and instead of 360 we can say angle average times I plus 1, I guess. Okay, and now last angle is equal angle, but before that we can say if and the difference between angle and last angle is less than angle average times something, let's say distribution, and we will define that float distribution uniform distribution. Then angle plus equal angle average times distribution. Okay, now we are able to control how uniform is our distribution of lines. Okay, the next step is to apply some noise to the lines, but we want to keep the origin where it is, and we want to keep the intersections with the box where they are. So we can define a couple of attributes using, first of all, a resample without resampling anything actually. Just disable this, and we just want the core view attribute. Okay, and then put down another angle to define our custom attribute. Let's call it distortion. Distortion is equal to chramp distortion based on the core view attribute. Smooth. 0.5, and this one will be 0. Okay, so if you visualize that distortion, okay, perfect. Now we can put down a point VOP. Let's start with an add this one, anti-alias noise, position here. We want distortion only over the X and Y, so let's use a vector to float to grab only the first two coordinates. Not this one. And we want to multiply the noise by our parameter, our attribute distortion. Multiply. And now, let me see. Okay. You see that now the distortion is not touching the origin and is not touching the borders. Obviously, we can promote a few parameters and go back. Okay, not bad. Okay, now we want to create the central circle here, but using the already existing points of our geometry. So my idea is to define a parameter called level, and level 1 will use the first points, level 2 will use the second points, and so on. But before that, let me rename some nodes here. This is the radial lines. The sample, this is the distortion attribute. Trib, and this is the noise. Okay. Put down a wrangle, which is the tail wrangle. So let me explain what I'm going to do now, because it sounds complicated, but it's not. The first thing to do is to count how many points each primitive have, and we take the minimum. In this case, the minimum will be 6, for example. Now, starting from, let's say this is the first primitive. Starting from here, let's say we have level equal to 4. We take the position of these points, this point here. We take the position of the fourth point on the other primitive, and we want to connect them. But we have to also consider the segment length. So based on this distance, we can add points here along this line, and we then can iterate over all the primitives and get something like this. Okay, so let's start creating some parameters. Int level equal to max1 chi circle level, and segment length okay, Segment length, we can use the same segment length that we have in the radial lines. Copy. Okay. Now let's grab the number of primitive. Prim count is equal to n primitives. And let's define a variable called endpoints min equals to -1. So the first step is to count the number of points for each primitive and take the minimum. So for int I equals 0, I less than print count I plus plus. Let's grab the points of the primitive. Prim points I if n points min is less than 0 or n points min is greater than the length of PTS, n points min is equal to length of PTS. Let me check this one. N points min, we should have 6. Yes. Okay. Now we can redefine level. So level is now the minimum between our level and n points min -2. We should have 3, okay, but no matter what we can do with the slider, the maximum is always 4 and the minimum is always 1. Okay. Next step. Okay, now we can cycle over the primitives. And say, grab the points of the first primitive. Grab the points of the second primitive. And I plus 1. And by the way, when we take the I plus 1, we need to modulo print count. Take the position of the first point. Take the position of the second point. Calculate the direction. And the distance. Okay. Now we can calculate the number of subdivision. Distance divided by segment length. Okay. Now we can append to our array the first point, TS1 level, and create the segments. As you can see here, the subdivision is not even. And if you take a look at the resample node, this checkbox solves exactly the same problem. So instead of using segment length here, we can use something else, like, I don't know, temp is equal to the distance divided by the number of subdivision. And by construction, we should have an even subdivision now. Okay, that's it. The last part is to delete all the points that are below level. For int j equals 0, j less than level, j plus plus, remove point 0, pts 1, j. That's it. Now we can change the level, and it's working. Okay.